Very good afternoon, students. As you all know that amidst this lockdown, the students got detached from their studies, and so our school have found out an innovative way to reach to the students through some online classes. So today I am going to teach Unit 1 of Chapter Machine for Class 10. So in the very beginning, I'll start with Unit 1. Unit 1 of the chapter Machine. Unit 1 of chapter Machine. In this chapter, the very first thing that we are going to study is the definition of machine itself. Unit 1 is basically the introductory portion of this chapter. Even though it is an introductory chapter, you must be very much acquainted with the technical terms which will be used in the later half of this chapter. So let us start with the definition of machine. As far as the definition of machine is concerned, the definition of machine, it is a device used to overcome load or a resistive force It is a device used to overcome load or a resistive force, change the direction of effort applied, change the point of application of force, the point of application of force to a convenient point and to increase the speed of work. So in this definition, you must have noticed some keywords. The keywords includes that these devices used to overcome load or a resistive force. Overcome load or resistive force means this machine will be used to lift a large load with the help of a less force. Example, screw jack. You must be very much acquainted with the fact that whenever a truck or a car tire gets punctured, the driver, in order to remove that punctured tire with a new tire, he takes the help of a screw jack. It is a small device attached with a long handle, which we tell lever. That handle will be rotated and one piston will come up. It will lift the car or the truck, and very easily the punctured tire can be removed, and then the new tire can be placed in place of that old tire. So this is the function of a screw jack, which is used to lift or overcome a resistive force by using very less force or effort. The second is change the direction of effort applied. This machine is also used to change the direction of effort applied. For example, if you want to lift a bucket full of water from the well, if you lift in the upward direction with the help of a rope, there will be you can lift at the most 1 to 3 bucket of water at a time. After that, if you continuously try to pull up bucket of water from the well in the upward direction, you are not only working against the force of gravity, but you are creating a lot of strain on your arms as well as on your back. In order to eradicate this sort of problems, what you need to do, that you can take the help of a pulley. If you take the help of a pulley, the pulley will be fixed to a rigid platform. Through the platform, on the platform there a pulley will be connected, a single fixed pulley. Through the pulley you pass a rope. One end of the rope you will apply effort, means you will apply force. Another end of the rope will be connected to a bucket. Now the bucket goes into the well. You try to lift the bucket in the upward direction, but this time you are not applying force in the upward direction. You are applying the force in downward direction, as a result of which the effort required to lift the bucket of water decreases a lot. So in this way, this machine, that is the pulley, it is helping you to apply effort not in upward direction but in downward direction, which is very convenient for an individual. The third keyword in this definition itself, you can find that this machine changes the point of application of force to a convenient point. Okay, for example, you are riding a bicycle. Now when you are riding a bicycle, you give force with the help of your feet onto the pedal. So the pedal is the point of application of force. Now this force is transmitted to a convenient point, that is the rear wheel, the wheel connected to the back of the bicycle with the help of a chain and a gear wheel or a toothed wheel having teeth. So chain is connected to that small wheel having projections or teeth known as toothed wheel or gear wheel. Now that chain is connected to the back wheel. You are applying effort in the pedal, but this effort is transferred to a convenient direction, that is the back wheel. The back wheel moves in the forward direction. The cycle also moves in the forward direction. And the third is, this machine helps to increase the speed of work. This is another key word. It helps in increasing the speed of doing work. For example, scissors for cutting clothes. You might have seen scissors. As far as scissor is concerned, the blades are longer in comparison to the handles. So when you apply effort onto the handles, the blades which are longer, it covers a greater distance, means the blade moves to a greater distance, means the load covers a greater distance. As the load covers a greater distance, the cloth gets cut down very quickly. It means the speed of doing work increases. Now this was the definition of machine, where I told you, with the help of this definition, I told you the different functions of machine. I will repeat the different functions which are given in the definition itself, that it is used to overcome a load or a resistive force, which I have explained with the help of an example, that is screw jack. It changes the direction of effort applied. I have given you an example, that is a single fixed pulley used to lift bucket of water from the well. Change the point of application of force to a convenient point. This is used in a bicycle where the rider applies force on the pedal, but this force is transferred to a convenient direction, that is to the back wheel with the help of a chain and a toothed or a gear wheel. And the last one is increase the speed of work. Example, I told you scissor for cutting clothes. Now next, in this particular unit, you will come across some technical terms. Some technical terms you have to come across. The first technical terms is load. What is load? Load is nothing but the resistive force to be overcome by a machine, or the resistive force which has to be lifted up by a machine is known as load. So it is the resistive force which will be overcome by a machine. Number 2, effort. As far as effort is concerned, in order to lift a load with the help of machine itself will not lift the load or overcome the resistive force. You have to give some force onto the machine, then only the machine will do the work. What work? To lift the load. or to overcome the resistive force. Now, effort is the force applied on a machine. The force applied on a machine to overcome the resistive force. The force applied on a machine to overcome the resistive force is known as effort. Is that clear? Now the next definition, the next technical term which you must be very much acquainted with is work input. What is work input? Work input means what work has been done on the machine. What work has been done on the machine. Because until unless you do some work on the machine itself will not do any work. Okay, if you simply tell the machine, hey, do the work for me, it is not going to do any work for you. So you have to do some work on the machine, only then the machine will do some work for you. So work input is nothing but work done on the machine in order to overcome a resistive force. Okay, in the previous chapter in class I taught you in the first term work, what is the definition of work or what is the formula of work. Work means force into displacement. So as far as work input is concerned, I am writing it symbolically. Work is W and input I am writing suffix capital I is equal to force. What force I am overcoming? The load, capital L. And there will be displacement. Displacement is of which force? The load. So I am writing displacement of load, small letter d, suffix L. So work input, capital W, suffix capital I equal to load into displacement of load. The next definition is work output. Work output is nothing. Since you have done a work on the machine, that is work input, obviously the machine is going to do a work for you. Whatever work the machine will do for you, that is the work output. So work done by the machine on application of an effort, means until unless you give an effort on the machine, the work also will the machine will also not do a work for you. So work done by the machine on application of effort. That is why I am emphasizing that you have to apply an effort, then only the machine will do a work for you. That is, there will be an output of work. Work done by the machine on application of effort. So the symbolically, if I want to write the formula for that, I am writing capital W suffix O equal to the force that I am giving on the machine to get an output is effort into displacement of effort. So this was the definition of work output. Now I am rubbing the upper portion. The next definition, number 5, is efficiency. No, sorry, before that, before efficiency, you have to know about mechanical advantage. Mechanical advantage. Mechanical advantage is basically nothing but the ratio of load and effort. Ratio of load and effort. In simple language, it is nothing but the ratio of load and effort. Now, if you want to understand, sir, ratio of load and effort, what is the meaning of that? Means how much effort you have applied in order to lift a load. Have you applied less effort to lift a load, or you have applied more effort to lift a small load? Okay. So the meaning of mechanical advantage is how much effort you have given in order to lift a load. The effort can be small, effort can be big, load can be small, load can be big. But literally it is nothing but the ratio of load and effort. It is the ratio of load and effort. So symbolically I write capital M dot capital A is equal to L divided by E. Now mechanical advantage can be positive as well as negative. Now when mechanical advantage will be positive? If effort is less than load, this is a symbol of less than. If effort is less than load, then mechanical advantage will be positive. If effort is greater than load, then mechanical advantage will be negative. So this was about mechanical advantage. Now the next technical term, today I am going to teach you up to the technical terms. In the next video, I will be sharing with you the remaining part, that is the principle of machine, the relationship, lever, the remaining topic of Unit 1. The next topic is your velocity ratio. Velocity ratio. What is velocity ratio? Now, velocity ratio is actually, it is equal to the ratio of velocity of effort to the velocity of load. Now what is the meaning of the ratio of velocity of effort to the velocity of load? It means when you have applied an effort on the machine, when you apply effort on a machine, obviously with a certain speed you have applied. So with what velocity you have applied the effort, and as such, since you have applied the effort with a certain velocity, obviously the load is also moving or it is getting lifted up with a certain velocity. So that is the meaning of velocity ratio. So it is nothing but the ratio of velocity of effort to the velocity of load. What is the meaning of this? Means with what velocity the effort has been applied, and since an effort has been applied with a certain velocity, obviously the load will also move or it will get lifted up with a certain velocity. So velocity ratio is, I am writing symbolically, VR equal to capital V, velocity of effort divided by velocity of load. Velocity ratio can also be defined in another term which I have to derive it right now. We already know that velocity is equal to displacement by time. So velocity ratio is equal to velocity of effort means displacement of effort divided by time. Velocity of, this is a division sign. Velocity of load means displacement of load divided by time. So velocity ratio is displacement of effort by time into cross multiply. Ultimately I get another definition of velocity ratio, which is equal to the ratio of displacement of effort by displacement of load. So velocity ratio is nothing but the ratio of displacement of effort to the displacement of load. The last definition is your efficiency. Efficiency. It is denoted, can you please come front? It is denoted by this symbol. It is known as eta, ETA. So efficiency is nothing but the ratio of work output by work input. Means ratio of work output by work input means how much work has been done on the machine, that is work input, and since a work has been done on the machine, obviously the machine is going to do a work and that is the work output. So today I am teaching up to this much today. So as far as today's unit which I have started, I taught you the definition of machine. From the definition of machine, I told you the different functions of machine, and then I came to the technical terms related to this unit. First I started with load, effort, then I explained you work input, work output, mechanical advantage, velocity ratio and efficiency. In my next video, I'll be explaining you about the principle of machine. Then I'll tell you that what are the two different kinds of machine. Then I'll tell you about the relationship between velocity ratio, mechanical advantage and efficiency. Then I'll explain you about lever. This will be all in the first unit. So as of now, up to this much today, I hope this unit you have understood. In case you have any query, all of you have my phone number. You can give me a call. And one more thing I would like to say, that amidst this lockdown, please stay home, stay safe. Thank you. I just forgot to mention one more thing, that as far as the definitions of mechanical advantage, velocity ratio, efficiency is concerned, these are the ratio of similar quantities. For example, mechanical advantage, it is the ratio of load and effort. The quantities are same, both are forces. So they will have no units. They will have no units since they are the ratio of two similar quantities. Velocity ratio also, it will have no units since it is the ratio of two similar quantities. Efficiency also, it will have no units as it is the ratio of two similar quantities. And as far as the units of load is concerned, it is a force, so its SI unit will be Newton. Effort, its SI unit will be Newton. Thank you.